Ok, alors, je vais chercher un petit truc mignon, je sais pas si c'est mignon, en fond. On a tout? On a tout, ouais, il y a un autre qui... Il y a du monde. Il y a du monde. D'accord. Il y a du monde dans ce truc. Okay, so welcome everybody. This is under Network Management Research Group, but this is not exactly about network management, or not only about network management. This is actually a special session on artificial intelligence and networking. Yeah, I think it works. And this is a bit of a trial balloon, I would say. I did a hot RFC in London on not only what network management could do with AI, but mostly not even what AI could do to networks, but what networks needed to do to help artificial intelligence. So that's why we're having this meeting. So I hope you're all here for that. Again, it's a bit of a trial balloon, so we don't really know where that is going to go, but we know that it's a topic that has had a lot of attention in the past year, I would say, and we felt it was important to at least have an open discussion about it. So again, why are we here? And a cute little typo. Why are we here again to discuss how this could evolve? We have two presentations. One's missing there. We have a network for AI, and then I don't know what the other title is, but there's two presentations, so it's going to take about, I would say, 35-40 minutes. And then we're going to come back, and we have a summary of some of the options that could move us forward. Again, by looking at it from different aspects, the easier things, the low-hanging fruits for this, and the things that get to be more complicated. And again, while you're here, what we would like you to start thinking is, again, a lot of people have talked about using AI in networking, but how would you also use networking to help AI? So I think this is a little bit what the first presentation is about. So Rachel, are you ready?
Thank you, Chairman. Thank you, everyone, for being here. It's so late. My name is Rachel Chen from Huawei. Today, my topic is about AI in network.
Change your slides.
Yeah. Yeah, the topic is about AI in network, which means networking for AI, so which is the chairman just mentioned. So it's basically not about the artificial intelligence for network. So we can start from the one typical use case about the DNN training platform. So this diagram shows the process how a DNN training going. So during the distribution phase.
Is the microphone microphone. Is everybody hearing? No. Yeah. So you should speak more closely to the microphone.
Okay. Okay, so maybe I can just, okay. During the distribution phase, the model parameters are distributed from the parameter server to all the workers. And during the aggregation phase, the workers calculate the gradients and then send them to the parameter server. So the traffic model here of the two phases are 1-to-many and many-to-one respectively. So if we reduce the network traffic between the parameter and switch, we can accelerate the training, which is very important because one training might take up to tens of days, as this table shows. So we have done some kind of experiment that shows that the data transmission between the parameter server and the workers takes the majority of the time. So we can see from this table, for example, the VNN, VGG DNN model, the calculation time takes about 280 milliseconds, while one single iteration, it takes around 7,000 milliseconds. So it's a majority of the time the data transmission accounts too much. So on the other hand, Scott Schenker's team from the UC Berkeley, they have do also some experiment about this to add the in-network computing and multicast to reduce the end-to-end training time of the VGG DNN training model, for example, to 1/29th. So theoretically speaking, when we introduce the in-network computing and multicast, we can still use the cheap switch rather than the much more expensive. So it's a cost-effective way to do the AI-related training. So why you might wonder the end-to-end training time is greatly reduced. So let's take the aggregation phase I mentioned. Okay, so does this work? Okay. Traditionally, the switch just work as a traffic mover. The workers upload the traffic from the workers to the switch, and then the switch just deliver the traffic to the parameter server. So what if we introduce the computing and caching capability into network? After the in-network aggregation, and we can transfer the results to a parameter server. So we can greatly reduce the traffic from switch to the parameter server. So which is almost the similar during the distribution phase. If we add caching capability, we store model parameters and then we distribute it to the workers. So we can greatly reduce the traffic from the PS to the switch. So most recently, there are many researches about the in-network computing. We just list some of them, the most important publications. For example, the Marco Carlini proposed in-network computing is a dumb idea whose time has come. The experiment shows that a large number of a large data reduction ratio and a similar decrease in workers' computation time. And also, Scott Schenker's team, they proposed the change network evolution for DNNs. So the experiment showing that optimizing the network fabric can improve DNN training time. And also someone from the Graham etc., they proposed this scalable hierarchical aggregation protocol, which is also almost the same effective way to improve. So, and also this year, in August, there will be a in-network computing related workshop in SIGCOMM. So you might be interested in that. And besides computing, in-network caching and also the consensus are also being researched recently with some extraordinary achievements. For example, the in-network caching, it can obtain the capability which is similar to the multicast. So all these looks quite promising, but you might wonder if we add X functions into the network, it might violate the end-to-end argument, which means we need to be cautious to add new functions if they are not used by majority of applications. And also, it might impact the TCP transport, the security and the privacy issues might emerge. So, or maybe we can first to avoid develop ad hoc solutions and also develop new abstractions of data plan and new architecture to make full use of new programmable devices. And meanwhile, these capabilities are generic enough and decoupled from specific applications. Then we tried it firstly in the constrained areas, for example, the data center related, data center network. And also, we need to keep in mind that the existing programmable network devices are designed for forwarding. So it's limited for the X functions. For example, some of the limitations are the size of the cache table, the number of bytes that the devices can manipulate on each packet, and also the floating points, etc. So we believe that we can propose a good research topic, which to jump out from the off-shelf devices and to find the sweet spot between the pains and the gains, and also to provide the requirements for the next generation programmable devices. So that's all for my presentation. Any comments?
I have a question. My chair hat off. So essentially what you're saying is that you feel that to introduce artificial intelligence in the network, we need to have distributed computing? Because you started from artificial intelligence and you finished with... Oh. Is it?
It works.
It works? Okay. Okay, so I'm saying that from your presentation, we understand that what you are suggesting is that to enable artificial intelligence in the network, you also need distributed computing in the network, because you started your presentation with artificial intelligence and finished with a call for action on distributed computing. Is that what you think is going to enable artificial intelligence?
I think basically in the first stage, we mentioned that we can try it in the data center related network.
Closer, you need to closer.
Okay, so the first trial will be in the data center related network.
Okay, well, we can take it off, because there's a lot of activity around distributed computing in the network, and that actually I would agree that this is a good application. Any other comments, questions? Okay, well, you have a question. Okay, good.
Diego Lopez, I guess I'm close enough, right?
Yes.
To the,
Sorry about that.
no, simply a reflection, because you mentioned this violation of the end-to-end principles or the end-to-end arguments. That can be right as long as I mean, the violation can happen if some entity in the middle decides, without the two ends of the communication, to make a deployment of any computational facility. But if it is either of the sides and I would like to see this more in terms of research on the side of the users. If I, as a user, instead of using only this and connecting to a cloud that is who knows where, I decide to push my function somewhere in the network under my control, we are not violating any end-to-end principle. I'm just pushing forward my end. Just as a...
I actually agree with you. I completely agree with you. I don't know if Rachel agrees with you, but I do. We can also discuss after the second. Presentation. Thank you very much, Rachel. And I think she needs to be very thanked because she prepared this on my request, like in 2 days. So thank you very much.
Thank you. Thank you for the chance. Thank you.
So Pedro will give a second talk, which is on essential artifacts for intelligent-driven networks. And I think we are learning and improving because I asked him to prepare this presentation 1 hour ago.
Yeah, but I am actually reusing. So if you have been, what's happening? If you have been in the previous session, maybe you are familiar with this already. So, but I will mention everything from different perspectives. That means concentrating in what artificial intelligence is and means for the network, especially for the network management, because we have two sides. That means that artificial intelligence can be used both in the data plane and in the control and management plane. So, but I will concentrate in general in how AI is can be exploited in the whole network, not just management but I will mention management, but it's not just targeting that. So, but I will first start clarifying some concepts. In general, many people say, oh, AI and ML are hand to hand. No, they are, but no, they are different. ML is one technique inside AI. So, AI has a broader spectrum, and many topics like perception, reasoning, and planning are not widely exploited currently in both, neither in the network, in the data plane, or in the management plane. So on the other hand, we have to differentiate that intelligence is not equal to intelligent. That means that we can manage intelligence information in order to take decisions for the data plane or the management plane, but that doesn't mean that that decisions are being taken intelligently, that they can be systematic based on intelligence information taken from the network. In this sense, intelligence emphasizes in the gathering of that information. We can use the intelligence methods to gather information and then use some systematic or AI that is the same method in order to take decisions from that information. On the other hand, intelligent methods can use telemetry information is more systematic in order to take decisions. Okay, so why AI must be in the network? Yes, in general and in the management plane specifically. The key part is that decisions in general, all in management, but also in the data plane, are more and more complex because the systems are bigger. They are composed of heterogeneous elements. Like we have virtual machines, we have physical machines, we have elements that can be moved, etc. And all of that must be joined together to make the system, the network system, work. So AI is required for that. Also, the operational environments are dynamic. That means that what I have just mentioned is not static. It's very complex and it changes on time. Moreover, network devices are becoming autonomic. We know we have here the Anima group that is working on that. So they have to take complex decisions that on their place. So they need some kind of deliberation, no? And actually, zero-touch networks that are being pushed recently are based on that sense, and programmability is a key on that approach. And finally, what I means is why not? AI, we must not be scared of AI. AI is just a tool. We can use it, or we cannot use it. We can decide to use or not to use it. But it's not something that we have to be scared. Also, exploiting AI into the network, we can push the concept of what we can say the AIDNet is intelligence driven networking, because it allows to easily process intelligence information and take decisions to drive the network. In this case, AI methods will have a big impact in the management and control of the network, and the knowledge derived from such data can be used to decide the strategic to take strategic decisions for the evolution of that network. We can talk now about the knowledge, intelligence-driven network, using this evolution from data to wisdom. Let's say we start from data, then we get information when we qualify the data, then we get knowledge in this sense when we understand the data, that information, and finally we get wisdom when we take decisions from that information. Then, in relation of this intelligence-driven network, we can say that the structure of the network system, in general, the structure is adapted by reasoning on the environment and the all stimulus that are being perceived from that network. So we can use intelligence data to manage properly and exploit its potential. So we have different kinds of ways to exploit that, and but AI methods in general, algorithms, etc., must be adapted, because currently they are focused on their specific targets, but we need to adapt them to work on network problems. So joint physical and virtual network elements can form a mass, in order to achieve the system goals. And finally, just to mention some issues that must be worked on, would be like methods that are used to retrieve the information must be assured. The quality of those methods must be assured in some sense. So we can be sure that the information we are retrieving for the intelligence, let's say the network intelligence plane, that information is from good quality. Let's say the metrics and data has been gathered following some procedure that ensures the types and quality of that information is consistent also. That information must be formatted using some ontology that's common, using common concepts, so different stakeholders, meaning different elements of the system and different systems, can understand that information. And finally, the protocols used to communicate that information must be also adapted, or at least well-defined, to be sure that the information is also to ensure the quality, but also that the information is transmitted, and communicated properly. And that's it from my side. Question, please.
Thank you. Can you go back to your slide number 2? I
Number
think, was it
two?
number 2? The one that was describing, no, fine, the one that says AI, what AI is and what, this one.
Number 1.
Yeah, I think this could be almost like a slide that everybody should look at, because this actually is very, I think it's a very important slide.
Okay.
Any other questions, comments?
Huawei Song from Huawei. Next slide. Can you explain a little bit more why network virtualization enable network automation? Second,
No, it's not just okay. That affirmation is that network virtualization enables network automation. It's not a requirement. It's that you can automate things, okay, automate network management, but you cannot automate the network without something virtual, because you cannot create a physical router, but you can create a virtual router. Is what I mean in that sentence is that you can automate the network itself, not just the management. You can automate the management of physical routers, physical elements, okay, but you cannot manage the network itself if you are not using virtual. You can use some slicing, okay, but this is some technique of virtualization. So you need some kind of virtualization technique in order to be able to automate actually the network, not automate operation of the network, but automate the network itself.
Another question.
Just to not contradict, but me complement what you mentioned. We may also automate the physical world, but for that we need kind of robots. In some data centers and others, you can switch racks with some automated robots. Stuff.
Yes.
But it's just that maybe the threshold is quite different. If it's software-based or virtualization-based, it's only a script or code you need, whereas in the physical world, we need physical things to automate.
Today is like something, I would like to see that just because it's funny, no? But
there are some people doing that.
Yeah, but in the future, I think that virtualization will take over. That's I think. So.
I think we will need most of both, but most of the virtual one, but also the physical one.
Yeah, of course.
Yonggen Hong, the ETLI. I have one question. Could you go to page 5?
Yes, here.
One more next. Sorry, could you to page 4?
4.
Yeah. I'm missing your the intelligence data. Which page you said intelligence data?
Yes.
So I'm wondering what's the meaning of intelligence data, because the data is not a goal. It can be a method to achieve a goal. So if we study or teach or make the algorithm model, then data is a source of the operation. So would you want to some intelligence into the data?
No. What I mean here is, sorry, I will go back. The intelligence data is, here. What I mean is that is here. Is data gathered for the specific purpose of knowing what to do in the network. It's not something like the data is intelligent by itself. No, it's intelligence data. Sorry for the nuance, but it is. That means that this data, you are getting that for the specific purpose of taking decisions. No, you are gathering in general. You are strategically gathering it. No, you are not systematically gathering it. So that's the reason, and that's why it was in brackets.
Okay, then in the real world there are lots of data. In data has its different features and different data model.
Yeah.
So do you want to, for example, make the standardized or well configured the data format?
Of course, you need some. As I mentioned in the end, you need some ontology and some common format to let's say encode that data that you have gathered. Of course, you need that. But here I push that the key is that how you gather the data and how do you exploit that data. Of course, we need some format, and I push also the format ontologies, etc., that we need in order to manage all that information in general that can be extracted knowledge and in general information.
Okay, thank you.
Very good presentation, and congratulations for this. I have two comments. One related to slide number 2.
Number 2, let's go back.
And
Number 2.
one related to number 3.
Number 3.
The comment, no, the previous one. Number
previous
2.
one. So here.
There is a very good example how AI was used and is used in networking with success. A tool from AI called rule-based system policies were invented 70 years ago in AI community, but it's embraced in networking because it's easy to apply in small, not in big numbers. That's a good example how the whole thing can work. In other words, something simple version of AI may substantially increase the intelligence and other things. So there could be. Now, unfortunately, I'll comment the second, number 3, is that why? It is obvious to me, at least, or maybe not to you, the management area, ecosystem, changed substantially in the last period and is moving towards managing the network services, not the connectivity. Of course. So personally, I will forget about the connectivity part of it here and add value, if possible, with some techniques in managing better autonomically, programmatically, end-to-end, zero touch, if possible, this new service network which appear, either per slice or any other form, and look for something simple to be used. So for the name of the game changes towards service management in practice.
Yes.
Yes, that will be my recommendation, how to move forward beyond these philosophical questions, which are valid, but a simple version is needed. These are my 2 comments.
Yeah, so we can say that is AI applied in network is in service management, let's say, in that sense.
Hi, Stu Card. So I do networks by day and I do machine learning on nights and weekends. And I've been trying to bring them together for many years. So I agree with much of what you said. AI is not the same thing as machine learning. Automation is not the same thing as autonomy. We've had all of these pieces separately in our networks for many years, frequently with a human in the loop. I think what's new is we're looking at deploying autonomous systems that continue to learn online. And so I'd like to introduce into the discussion the word surprise. My work in machine learning mostly uses genetic programming. I evolve code, and it surprises me. And frequently it surprises me in ways that are not conducive to my achieving the engineering solution that I sought. But if it didn't surprise me, I would argue that it's not terribly interesting. Now, in operating networks, we generally hate to be surprised by our networks. So I guess what I would like to throw out there is, especially if we start, for instance, evolving protocols, there's absolutely no reason why a genetic programming system can't be used to evolve a protocol. What are we going to do if these things, on the one hand, either fail to surprise us, which is indicative that they are not really doing anything much new for us, or if they do surprise us?
Yeah, in both scenarios are good. Either they don't surprise us, so everything is doing what we want to do, we will be happy. But if they surprise us, what I mean is that we are in control of that. That means artificial intelligence doesn't mean that uncontrolled things, no? we will not just put a seed there and let's hope that the network or network system or service is working properly. No, we establish some policies, rules, etc. So our ecosystem of intelligent methods is working inside our parameters. So in any way, it will be good.
Okay, so I'm relaying a message from the Meet Echo from Jefferson. Since you are using terms from the other area like AI ML, it would be nice if you could bring some references. And the second point is more in the form of a question. Would it be useful to have a document on AI ML terminology in network management?
Okay, good comment. Maybe it's good to push forward this terminology and also maybe a broader ontology in that sense. That means not just definition of concepts, but also the relation of those concepts that they have. That's, again, taking the words of this commentator, I don't remember the name, it was to define the AI, make reference or where to get proper information on how to get the proper definition of AI, ML, etc. Okay, I agree with that.
That would be really. I would say this is very good, and maybe a generic sense of the networking world. Yes.
Okay.
That would be really good. Any other question? I think there is another question.
While Jerome is going to the mic, just because we were discussing about some references, doing a bit of promotion, there have been recently a survey published on machine learning for networks. I can give you the reference. I can put it in the minutes if you like. It's quite, I would say, extensive survey, and I think it could be a good basis for this discussion or the further steps.
Jérôme François Henria. Maybe just very going back to the previous question. Yes, I think it's good to have some references. Then I don't think it's I think it's not the role of the NMRG group to define what is AI and ML. I think it's
no. Sorry, with the reference, okay, but we will not define that. We will gather the definition. We should not. I agree with you. We should not. Define
I think
that.
you can. Probably you can really find nice reference that
but
there's a difference.
It's good to have all that references, all that definitions in one document. So as a guide to say, well, I can go there and find what
but what I would say is that in the area of AI, there are already some surveys and things like that refers and do this gathering.
It's okay, but we need some kind of manual.
Just a small interruption. We will close the line after Alex because we still have also to go back to the chair slides because we would like to shape a bit the discussion and have like a quarter left.
And so then maybe one question on your, I think slide 7 or 6.
Just let me know when I stop.
7?
No, 7.
No, 6. This is 6. 6.
This one, the last one. Okay.
So here you talk a lot about the data. So what's the idea is that we should work on the data and data format a priori, or could we rely on artificial intelligence in order to, let's say, define kind of automated way the data we want?
Yeah, but we need some kind of ontology. We need to define the concepts, what I mean, the relations and how, and also the format and how to encode that. We can rely on some intelligent methods in order that can this, for example, determine the attributes of the information we are gathering. But the resulting piece of data, in order to be useful, need to follow some kind of ontology. So otherwise, it will be difficult, and you must adapt all algorithms to that specific data. If you follow an ontology, you can use any algorithm that is, of course, using that ontology, but that kind of nuance is important.
Is there any option that if the problem is well specified, the problem you want to target, that the method can find the ontology actually?
Yeah, we have to. So that's
I mean, not manually.
No, the ontology is we can define extendable ontology that can be increasingly blah, 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 blah with the algorithm. Okay, but we need to control that part. We need to define that. At least let's say, metadata.
I think we should maybe keep this, in my opinion, keep this idea of open to, if you want really to think about the application of AI and not want to restrict too much now, I think we should not say that we...
Yeah, but we need that. I insist, we need that because otherwise you are just working on your specific problem. And of course, that's not bad, but we are working on general problems. Okay? That's what I mean, that we need some kind of abstract ontology. Okay. We need something that can...
You may disagree, and maybe we have to still have one comment, and we would like to have a more general also point, not only towards you, I mean, Pedro.
Yeah, sorry.
No, it's fine. It's perfectly fine, but we have to also.
Yeah,
open the floor.
for me, it's okay.
Hello. Hello. Can you hear me? Yeah. I'm Philip
don't know.
Eardley. I just wanted to follow up on the previous comment about surprise in networks. And I think that's a very good point. For lots of network operators don't like surprises. A very conservative kind of by institutional culture, a very conservative organizations. And I think it would be interesting in the research group to kind of look at some of those kind of broader issues about what's bad about this AI in network management, or how it's going to change how operators are going to run their network, not at sort of very detailed level, but kind of at a more a higher level.
Yeah.
And yeah, I think that'd be interesting. This, sort of how do you, what happens to kind of rollback of if you change something. At the moment, you have quite a good idea. Oh, we've made a little change. It didn't work. We can roll it back. Yeah. And I kind of feel that in this, it's going to be much harder to do that sort of thing. And so people have, will the human be able to come in and control in some sense if something goes wrong, or do you just have to leave it to the AI to work out how to get out of this problem that's happened? And those sort of higher level questions, I think, would be very interesting research topics, as I'm not aware of kind of work to address that.
Yeah, okay.
Thank you for the comment. I fully support this comment, and especially also because I think here in IETF, it's also quite conservative. And I think, for instance, most of our protocols are really deterministic. I mean, we define every state of the protocol, the behavior, the packets we expect, and if something goes out of this, it's usually dropped or discarded. And if we move towards more machine learning, especially AI, it's a bit different. Machine learning approaches, we have to understand a bit more of randomness or stochastic aspect of the behavior, which is quite different from the determinism of current protocol. So when those things will collide, it will be interesting to see.
Yeah.
Thank you.
Okay, so now we go back to the slides that we had prepared. Pusher. Okay, so this is something that we've discussed together. So there's a number of options, and I agreed with the previous presentation that machine learning and AI, there are tools, they're not ends in themselves. So the current low-hanging fruit, if you look at what is being published right now in a lot of conferences on AI and networking, is that you take an AI algorithm, you apply it to a network problem, and you see what happens. And there's, again, a lot of people have done that. There's a lot of results. And I think some of it, for a research group, it's interesting, makes nice paper, but there's probably a more interesting way to look at it. Actually, a few months ago, I listened to a presentation from Andrea Goldschmidt, who actually had developed an AI approach, actually for the physical layer of a network, which was like it was actually very refreshing. And her thing was that she wanted to develop a network-specific AI or ML algorithm to solve a specific problem. In her case, it was diffusion of information. And then once you have them, then turn them around and say, well, now we knew that they worked in that concept. Let's turn them around and see if they can actually themselves now start produce new paradigms and that could be helpful in the IETF. So I think this is more interesting because it starts from the knowledge that people have from the network. It's not some generic thing that we can come out of the web. I have, and I think this is what a little bit of Rachel was doing, I have another approach. And I think the second one is very much appropriate for the people in network management and people who actually do fault detection and things like that. The other one, which is a little bit what Rachel was doing, and it is some thoughts that are outside of this room and relate to all kinds of things related also to edge networking, is now you add some computing in the network. And then you see how that added functionality, because now you have way more computing power and things can be updated, can actually support the AI algorithms to perform network tasks. I tried to find the person, but he was not at the IETF. There was a presentation in London about somebody who had used an AI approach to do congestion control in networks, which was kind of fun because first, it was new, and second, it was a good application for training an algorithm to detect when things start going badly. And it was very interesting. But then again, see, once we have these algorithms that are part of the computing inside the network, again, the other thing is, this is the thing that Laurent and I really believe in, is the same thing. You flip them around. And now by flipping them around, you can say how these algorithms in their own way can influence the behavior of the network and not just being part of the, the non-forwarding functions. There is a common issue for all, there's a few common issues for all of this. There's always the thing, should it be centralized? Maybe for some management functions, it's maybe better to be centralized because you want to have somebody who actually can make, at one point, it goes back to making a decision about the whole network. Obviously, in the case of a distributed intelligence and computing, the decentralized approach is more, maybe more appropriate, but they all share into a few things. They need CPU, they need energy, and then you get into sustainability issues. If you just start distributing, how do you make sure that they're federated and synchronized? And again, that's what is needed inside the network to support that. And of course, performance. If we're going to do that and it's not more performing than what we're doing right now, it makes nice papers, but it's not the tools that the first presenter was doing. So we would like to open the discussion. We do not have, and just to start, we do not have a specific way forward. We're very much interested to know what the community thinks about. Again, if we take AI as a tool, it may not have, and again, decentralizing it, it may not have a role as a specific research group. It may have a role in a number of research groups. Obviously, there's a lot of applications for it. There could be also future work that's more into a single research group. So we want to open the discussion to people who are here and to see what people are thinking. So now we have about 12 minutes. Time flies. And please, we open the floor. Okay, so nobody's voting.
Don't be shy. You were lining up before for the comments. So now it's time just to express different viewpoints, different opinions, ideas, things you think are not tackled, things you should not tackle, or whatever.
So this is Alex Clem. So just as one comment, I think in terms of what I would find interesting is, on one hand, basically there are the AI applications and so forth for network management, and this is NMRG and so forth, so I understand that. I think all those applications are actually fairly straightforward. Basically, the applications, about there are not so many surprises there. What I think for research group is actually more interesting is to apply to really actually networking problems. So not specifically network management, but networking problems. So for instance, routing decision and so forth. How can AI help with that? All the work basically on the controllers, path computation elements, et cetera. So I think trying to apply or see basically what role AI can play to make networking better is, I think, actually the more interesting question, or the question that I would find more interesting as a research group than looking at the management problems. So it's just from where to look at. developers. Just another reflection that comes from the some conversations I have had with other colleagues is about the idea that we should start thinking about security as well. Normally, we tend to think about AI as a helper, as a tool. But tools can be always. You can use a hammer to nail down, to put a nail on the wall, and you can use a tool to. You can use a hammer to kill someone. And AI can be an extremely complicated tool if it's used by the wrong hands. And you think about the typical script kidding, that instead of running a POSCAN, can have an AI-enabled POSCAN, and can look for vulnerabilities. I'm not talking about Skynet yet, okay? So think about, no, Pedro, think about that. Well, so some kind of these surprises that start to behave in a way in which is not, and I'm not saying that we need. Do you remember the Turing Institute in the cyber? What is called? Neuromancer. And this is something that we should. I mean, not talking about this exactly, but about an environment in which you can somehow find ways of reacting to potential attacks that are enabled by AIs or they are supported by AIs. This is one thing. And the second thing is some mechanisms for doing some kind of attestation or security assessment of the AI behavior is something that we should consider as well. Before, I mean, let's put security as very often as ahead in the design and the thinking process.
Philip Erdley, I mean, AI is driven by data, isn't it? So if my network is being run by the way it's operating is being driven by AI decisions, as an attacker, all I've got to do is work out how to get data in that manipulates my AI to get my network in some state that's a disaster. So I think, I mean, in terms of this, I think the first one is fair enough and will continue to happen. But in terms of the others, I think it'd be interesting to think about what problems AI can cause and how to solve those. We just sort of touched on one, Diego and I.
I can actually make a comment on this. I think also we have to define what we call intelligent devices and things. I was at an edge computing conference last week or the week before in Boston, and people were talking about the immense amount of data that will be accumulated by intelligent vehicles. And this is actually completely driven by the insurance companies who want to have access to every instantiation of every sensor. And that creates these terabytes of information and data that have to be moved across the network. And that's why this is actually what the bottom ones are about a lot, is one, what is needed in the network to support that incredible amount of data, which is essentially coming to the edge, and how do we need to send it completely back to the through the cloud for all the processing, or could there be some intermediate processing that would reduce the load on the hops? This is actually why these two other elements are there, is that when we think about intelligent elements and data, I don't think we actually, it was shocking for me, and they have the same thing with surveillance cameras in smart cities. So I think there's this idea that what also can these algorithms can help us do to reduce the size and the sheer overwhelming, quantity of information.
So, hi, Padma, Huawei. So it's interesting because I had a comment both regarding the surprises and how much data we have to process. There's a couple of things that come to my mind is regarding surprises, is how much control do we have? What is the privacy, for example? How are we going to maybe reduce the amount of data so we reduce the amount of surprises? Because by feeding so much data, we might actually come up with answers that we didn't even want to ask the question. So I was thinking that security and privacy should be really part of this, of any kind of work that we're doing. That's one. And second thing, I'm going to throw a buzzword here, but I think part of this is also what is the intent of anybody who's actually managing a network? And does that intent conflict to another, let's say, two different administrative domains, and do they have conflicting intents? And that muddies the water a little bit, but I think this is something we need to think about as well, is what do you do when you have conflicts and you don't really get what is the end goals when we're talking about goals?
Jérôme, INRIA. So first of all, just emphasize what I've been saying regarding security and privacy. So I think we should take the opportunity of...
Can you speak closer to the mic?
We should take the opportunity of AI in order to actually collect less data. I think we are usually talking about collecting a lot of data with AI, which is not, always necessary. So maybe from a user perspective, I would be happy if with the AI we can at the end finally collect less data. So I think this is an opportunity to take. Second, regarding security, yes, I think what is a hot topic in AI, also adversarial learning, in machine learning, let's say, adversarial learning. So if you put AI for doing some operation, you increase incredibly your, let's say, attack surface. Particularly, I really like the idea of putting something to the network computation. But if you use some AI as black box and you don't really know what happens here, actually at the end you can end with a very nice attack, because you don't really handle the process. And if you want to keep the line weight and you don't know exactly what happens, then you can re-end in hyphen loop or things that really impact your performance. So I think it's very important to take that also into consideration.
Hi, this is Pedro Aranda, Universidad Carlos III Madrid. Just a linguistic clarification coming from my background, which was former Telefonica, former network operator. I think we shouldn't be mixing their intent and objectives regarding the last thing. One thing is the objective a network operator may have, and that's that the network runs. And I think you may have the same, and then you may have conflicting policies, but I wouldn't use intent there. In that specific, I would use simpler words like objectives and policies.
This is a topic for tomorrow.
Liang from China Mobile. I have a general comment on this topic. So I think artificial intelligence is a great topic to be tackled in IETF. Especially for network use applications. But in terms of the scope of IETF or IRTF here, I think it's much more interesting to tackle the problem of network for artificial intelligence instead of artificial intelligence for network. Well, I think it's more important, for example, as an operator. Actually, in the current network, we have a lot of data from the network. Not talking about using new technologies, for example, telemetry or things. Using the existing technology, we have a lot of data, but we don't know how to use it. So, and those data are not collected in a very efficient way. It's just useless. It's there. So it's very important to tackle the problem, how we can collect the data from the network more efficiently. And to filter out the data to be the input of your AI algorithm and to get the output you want. For example, if we have a long, massive collection of bandwidth, live bandwidth data from the real network, would that give you a prediction of how you configure different domain of a network to give you an output of, for example, for low latency network? We have some research project with vendors to tackle this, like converting the dimension of how you, using some type of algorithm to converting the dimension of from bandwidth to latency using some existing data. Yeah, so that's what I mean. I think it's more interesting to tackle the problem how the data can be collected, how the network technology to support AI algorithm instead of investigating AI algorithm for networking. Thank you.
Thank you. Alex, we're out of time. Okay, so I think just 1 hour for this was obviously not enough. And I don't think we came up with I think we still have these two things, AI for network and network for AI. And I think it follows pretty well what Laurent and I had discussed, that maybe there could be two different types of approaches to this. So AI as an application in the network and the network being a feeder for the AI. And we can continue the discussion. I don't know, there's a number of mailing lists that have been involved. And I don't know exactly how we're going to do that, but we'll find a way.
Yeah, and to build on that, I would say, if you're interested, if you think we need to keep having meetings, discussion, or try to organize and structure those questions either in IETF or IETF scopes, okay, we are still here. I'm here also tomorrow, so come to us. I mean, not only to us, I mean, anybody can discuss, but we have to understand, you can use the mailing list, or if we need to prepare something for the next meeting, in between the meeting. But if you want to go beyond this just 1 hour discussion or the previous attempts, we need to understand a bit more to define some directions or maybe some areas where we say we want to give priority to this because there is 5-10% that wants to invest a bit of time on that. So just that we go the step beyond.
And so because I'm the one who started this and I launched the balloon, thank you so very much to be here. And again, let's continue the discussion. I think it's kind of cool stuff. Thank you very much. Oh, cool. We're not going to have a workshop with 60 people. I'm not. Oh yeah, no, I'm not. And I know you've been talking to a lot of people about, but coordinate with me.